but can the receivers get far enough down the field?
Rodgers in trouble.
It's going to get there.
He turned 32 yesterday. Does he have a vintage moment in him? In the end zone, it is caught for the win. Richard Rodgers with a walk-off touchdown. A game ender for the Packers. Total disbelief at Ford Field. The Packers saved by the face mask call, given one last chance. And Aaron Rodgers heaves it as far as he can. And Richard Rodgers boxing out in the end zone for the touchdown. The son of a former Cal football player who was involved in the band play, one of the all-time game enders in football history, the Stanford-Cal game of years ago, 1982. Now the son comes up with the play of his own.
Well, right from the start, again, you let Aaron Rodgers out of the pocket.
Today, we are going to be breaking down the physics of one of the greatest throws ever made in the history of the NFL. Given one more chance to beat the Lions at Ford Field on Thursday Night Football, Aaron Rodgers had no time left and 61 yards for the win. Down by only 2 points, a touchdown would give the Packers the victory. Rodgers, after escaping away from a sack, steps up and heaves the ball in the air for the game-winning score. Now the real question is, how in the world is this throw possible? First, let's start at the beginning of the throw. Even though the pass counted for 61 yards and the line of scrimmage was at the 39-yard line, Rodgers actually released the ball at the 35-yard line, as seen on this video from a fan. Rodgers, standing at 6 feet 2 inches tall, actually released the ball approximately 8 feet above the ground. Combined with a crow hop and a high release point, Rodgers was able to get even more energy on the ball. Although this image is blurry, we can see that at the point of the release, Rodgers had his arm angled at 61 degrees. This angle must be very precise to ensure a good throw. A larger angle would have caused the ball to go straighter up in the air. Without more force on the ball, the throw would have ended up short of the goal line. The throw from Rodgers traveled in the air for an astounding 4.15 seconds, which is even a solid hang time number on NFL punts. The ball ended up reaching its maximum height at 2.08 seconds, which is about half the time the ball was in the air. During that time, the peak height was about 78 feet. Funny enough, the NFL rulebook states that each stadium must have at least 85 feet of clearance so that a punt or even a throw can't interfere with the play. That means that if Rodgers would have released the ball with a higher arm angle, the ball would have traveled higher in the air and possibly hit the rafters at Ford Field. The ball would have dropped straight down, and the Packers would have lost the game. The actual angle of the ball's arcing path was at 53 degrees. That's only an 8-degree difference from the arm angle on the throw. Amazingly, the ball traveled at 57 miles per hour, 33.5 miles per hour in the X direction, and 45.7 miles an hour in the Y direction. At the end of the throw, there to catch the ball was Aaron Rodgers' tight end Richard Rodgers. Standing at 6'4" and 257 pounds, Rodgers caught the ball about 9 feet in the air. At a throw of this magnitude, there could have been many different factors to change the outcome of the throw. However, the Lions play indoors, so there was no wind or abnormally high or low temperatures to play a factor in the ball's path. Aaron Rodgers' Hail Mary pass was 61 yards. I'm going to curl up and see how far I can get it. I was 24 yards short of Aaron Rodgers' 61 yards, and that was with 19 miles an hour of wind helping at my back. Right here is a side angle of one of my throwing attempts, and as you can see, my right arm is angled at about 90 degrees, so my ball did arc a little bit higher than Aaron Rodgers did, but with not as much force, my ball did not travel as high or go as long. Here's my arm at the top of my release point. As you can see, like Aaron Rodgers, my arm is about 2 feet above the top of my head. The straighter my arm is, the straighter the ball's path will be.